Imagine the internet as a global postal service, tirelessly delivering messages between billions of devices every second. Instead of envelopes and stamps, this digital mail system uses packets of data to carry information from one place to another, connecting people, businesses, and ideas across the world. When you visit a website, your browser sends an HTTP request, a digital postcard, to a server somewhere on the internet. This request is like a carefully written note, asking for exactly what you want to see or do online. The request has an address, such as youtube.com, which tells the internet exactly where to deliver your message. This address is like the destination on a real postcard, ensuring your request finds the right server among millions. Inside the request is a message, maybe something like, "Send me the squirrel obstacle course video." But it could also be a search term, a login attempt, or a request to post a comment. Every action you take online creates a new message, each with its own purpose. The server receives your request, processes it, and packages up the web page or data you asked for. It then sends back an HTTP response, which is like a digital care package filled with everything your browser needs to show you the page. This response contains all the ingredients, text, images, videos, and code, that your browser assembles into the website you see. Without this exchange, the web simply wouldn't work. Every click, every page load, and every interaction is a rapid-fire exchange of these digital postcards, happening in milliseconds. The speed and reliability of these exchanges are what make the internet feel instant and seamless. Why does this matter? Because these messages reveal exactly how websites work, and how they can break. If something goes wrong, it's often because of a problem in these hidden conversations. If we intercept these packets, we can see the instructions being sent and the results coming back. This gives us a behind-the-scenes look at the inner workings of web applications, exposing both their strengths and their vulnerabilities. Tools like Burp Suite act like a magnifying glass for these digital postcards. They let us pause, inspect, and even modify the messages before they reach their destination, giving us unprecedented control over the flow of information. By doing this, we can understand, test, and manipulate the web's hidden conversations. This is how security professionals find bugs, test defenses, and learn how to protect websites from attacks. This is the foundation of web security testing, learning to read and control the flow of HTTP requests and responses. Mastering this skill is essential for anyone who wants to understand, secure, or even build modern web applications. Welcome to your first step as a digital detective. By learning to see and interpret these HTTP packets, you're unlocking the secrets of the web and beginning your journey into the world of cybersecurity. To begin our journey into web application testing, the first step is to configure Burp Suite as our man in the middle. This setup is essential for intercepting, analyzing, and manipulating the data that flows between your browser and the internet. By doing this, we gain a powerful vantage point to observe and control every request and response. Burp Suite acts as a bridge, sitting quietly between your browser and the wider internet, inspecting all the traffic that passes through. This allows us to see exactly what data is being sent and received, which is crucial for effective security testing. Start by launching Burp Suite and navigating to the Proxy tab, then select Options. Here, you'll find the settings that control how Burp listens for incoming browser traffic. Pay close attention to the address and port. By default, it's usually set to 127.0.0.1 on port 8080. This means Burp will only accept connections from your own computer, keeping your testing environment secure and isolated. Next, open your browser's network or proxy settings. Enter the same address and port you saw in Burp. This step is vital. Without it, your browser's traffic won't be routed through Burp Suite, and you won't be able to intercept anything. For secure HTTPS sites, Burp needs to decrypt encrypted traffic. To do this, it uses a special CA certificate, which you'll need to install in your browser. Download the certificate by visiting in your browser. Import it as a trusted authority. This step ensures your browser trusts Burp to decrypt and re-encrypt secure traffic, preventing security warnings. With your proxy and certificate configured, return to Burp Suite. Make sure Intercept is turned on in the Proxy tab. This enables Burp to pause and display each request before it reaches its destination. Now try visiting any website. You'll notice the page doesn't load right away. Burp has intercepted the request, giving you a chance to review it before it's sent. In the Intercept tab, you'll see the raw HTTP request, frozen in time for your inspection. This is where you can really start to understand how web applications communicate. You have the power to examine, modify, or forward the request. This is invaluable for testing how applications respond to different inputs or unexpected data. With this setup, you gain complete control over your web traffic. You can monitor, analyze, and manipulate requests and responses in real time. You're now fully equipped to inspect and manipulate web requests as they happen, opening up a world of possibilities for security testing and learning. This is your digital workshop, a place to experiment, learn, and sharpen your skills. Let's get hands-on and start exploring the power of Burp Suite. With a request captured, let's break it down. The request line shows what you want, get or post, and where, the URL path. Headers provide context, like your browser type, user agent, or accepted content. Cookies act as your ID badge, often containing session IDs. Tweaking these can change your identity or permissions. Post requests include a body, usernames, passwords, or other data you submit. This is prime territory for testing. URL parameters like ID = 123 are also user-controlled inputs. Changing these values can reveal hidden functionality or vulnerabilities. Every part, the URL, headers, cookies, body, offers a lever to pull. By mapping these, you discover where you can influence the application. This is how you find the weak spots. Let's start experimenting. The Proxy Intercept tab is great for catching traffic, but for real testing, use the repeater. Repeater is your lab. Send any captured request there to modify and resend it as often as you like. Right-click a request and choose Send to Repeater, or use Ctrl+R. In Repeater, the left panel holds your editable request. The right shows the server's response. Change URLs, headers, cookies, or parameters, then hit Send. Instantly see how the server reacts. Try tweaking a user_ID, session cookie, or request method. Each change is a new experiment. This rapid feedback loop is the heart of manual security testing. Test dozens of ideas in minutes. No risk to the original request, just controlled chaos in your sandbox. Repeater is where discoveries happen. Dive in and start tinkering. With Repeater, you can test for real vulnerabilities. This tool lets you take a single request and modify it as many times as you want, giving you the freedom to experiment and observe how the server reacts to every change. It's like having a safe playground to poke and prod at a web application without the risk of breaking anything for real users. For SQL injection, add a single quote to a parameter. Does the server throw a database error? If you see a strange message or a stack trace, it could mean the application is exposing its database logic. This is a classic sign that the input isn't being handled safely, and it's your invitation to dig deeper. For cross-site scripting, XSS, inject a script tag into a search or comment field. Does your code execute? If a pop-up appears or your script runs, you've found a spot where user input isn't being sanitized. This could let attackers run malicious code in other users' browsers. For IDOR, change a user_ID in the URL. Can you access someone else's data? If you can see another user's information just by tweaking a number, the application isn't properly checking permissions. This is a serious security flaw that can lead to data leaks. Try command injection, add ls or nwomie to a parameter. Does the server respond differently? If you get a directory listing or a username, you've discovered a way to execute commands on the server, which can be extremely dangerous. Test authentication bypasses, remove the session cookie or access/admin directly. If you're still able to get in, the application isn't enforcing proper access controls, leaving sensitive areas exposed. The key, question every input. What happens if you change it? Try unexpected values, long strings, or even special characters. Sometimes the smallest tweak can reveal a hidden vulnerability. Repeater lets you safely probe for weaknesses, one request at a time. You can replay, modify, and resend requests, watching for subtle differences in the responses that might hint at a flaw. Think like an attacker. Be curious, persistent, and methodical. Don't just look for obvious issues. Dig into the details and always ask, what if? Every odd response is a clue. An error message, a delay, or a strange output could be the thread that unravels a much bigger problem. This is how you uncover hidden flaws. By thinking outside the box and following the evidence, you can find vulnerabilities others might miss. Your toolkit is only limited by your creativity. Combine different tools, techniques, and ideas to approach each challenge from a new angle. Start testing and see what you find. Every test is a chance to learn, improve, and make the web a safer place for everyone. Finding vulnerabilities isn't just about sending requests, it's about reading responses. Start with the HTTP status code. 200, OK, 404 not found, 500 internal server error. A 500 error often means your input broke something, potential vulnerability. Look for your input reflected in the response, especially for XSS testing. If your script appears unencoded, that's a red flag. Detailed error messages can reveal database names, table structures, or even code snippets. Always read the full response, including hidden HTML comments. Compare responses. Does a payload change the length or content of the page? Use Burp's comparer tool to spot subtle differences. Anomalies in status codes or response sizes are clues. The best testers are careful observers. Decoding responses is how you confirm and refine your findings. Let the server's answers guide your next move. Manual testing is powerful, but automation is essential for scale. Burp Suite's intruder tool automates attacks by sending thousands of requests with different payloads. Right-click a request and send to intruder. Mark payload positions, like a password field or ID parameter. Load your payload list, common passwords, numbers, or attack strings. Start the attack. Intruder fires off requests, logging status codes and response lengths. Sort results to spot anomalies, a 200 OK and a sea of 403S, or a longer response indicating success. Use Intruder for brute forcing, fuzzing, or mass vulnerability checks. Automation finds what manual testing might miss. Focus on analyzing results, not sending requests. Intruder does the heavy lifting. You hunt for the outliers. This is how you scale your testing. Let's find a real XSS vulnerability in a blog's comment section. Set up Burp Proxy and submit a normal comment. In Burp's HTTP history, find the post request for your comment. Send it to repeater. In the request body, replace your comment with a script. Send the modified request. If the server responds with 200 OK or a redirect, your comment was accepted. Refresh the blog post in your browser. If an alert pops up, you've successfully injected JavaScript. This proves the vulnerability. Attackers could use this to steal cookies or hijack sessions. Always verify your findings in the browser. To level up, master Burp's extra tools. The logger records every request, never miss anything, even if Intercept was off. Decoder translates encoded data, URL, base 64, hashes, making it readable or ready for payloads. Comparer highlights differences between requests or responses, perfect for spotting subtle changes. Use it to confirm blind vulnerabilities or track down tiny clues. The built-in Burp browser is pre-configured for testing, no setup needed, no interference with your main browser. Keep your testing environment clean and efficient. These tools save time and reveal what others miss. Combine them for maximum power. Organization and efficiency are your secret weapons. That's how you become a Burp Suite Pro.